Hi, this is Mrs. Overmeyer. Thank you for tuning in to the Scientific Method Review. For this review, what I'm going to do is I'm going to give you a scenario, and then you're going to have to come up with defining the different parts of the scientific method, such as the observation, problem, hypothesis, and then also kind of come up with the experimental design, which includes identifying those variables as well as the experimental group and the control group. Okay, so feel free to pause the recording if you need more time to kind of come up with your answers. So here we go. So here is the scenario. I love gardening, so I decided to make my scenario about plants. So it says, recently I decided to plant some raspberry bushes on the south end of my garden. I bought 2 plants, brought them home, and then did some research on how to take care of them. The research said that depending on what region of the United States they're growing, that I may need to add more water in addition to the rain that they get. So it didn't tell me much more than that in my research, so pretty vague. So I know that I may need to water the plants, every week in addition to any rainfall we might get. So did you catch what my observation would be in that scenario? What would be my observation? Well, if you said the raspberry bushes may need watered more, depending on the amount of rainfall we get, you're correct. This is a little bit different than what you had, what the examples were in the module. In this scenario, the observation is the research that that I did, and you didn't have any examples like that within the module, but research can be considered observation. So now that we have the observation defined, let's define the problem. What is the problem? What question am I asking myself? Remember that we always state the problem in the form of a question. So what is the question that we're going to be trying to solve here, or we're going to be investigating? Well, if you said, will I need to water my raspberry bushes regularly in order to produce a good crop of raspberries? You're correct. That question came from the observation. We can connect the question to the observation. The observation was about the research, and we're asking, okay, so, do I need to water them more than, just the regular rainfall that they'll get in order to harvest a good crop of raspberries? So now we'll think about that question and formulate a hypothesis. Now, when we formulate the hypothesis, remember that a hypothesis is just an answer to that question. We can think about it as a prediction that usually has a cause-effect statement. So think about it a minute and come up with a good hypothesis. And remember, it has to be testable. Well, this is the hypothesis that I came up with. So if yours is similar, good job. My hypothesis is if I water the raspberry bushes each day, they will produce more raspberries. That's my prediction. And that's answering my question, right? Will I need to water my raspberry bushes in order to produce a good crop of raspberries? And the hypothesis, if I water the raspberry bushes each day, they will produce more raspberries. That's my hypothesis. So now that we have the hypothesis, we need to test the hypothesis with an experiment. And so if you think back to what you learned within the module, within the lesson, remember that an experiment has to have at least one experimental group and one control group. And so think about how you would set this experiment up using those 2 raspberry bushes. So the experimental group is the group that will receive the treatment. That means that they'll receive whatever variable we're testing. And the control group then would not receive the treatment. So what is the treatment that we're talking about here? What treatment are we talking about? Right, it's water. So the experimental group will get some extra water, and the control group will not receive the extra water. Once we've set up our experimental and control groups, we need to identify variables that could affect the outcome of our experiment. Because we want to know, once we get the results from our experiment, we want to know that those results are attributable or are because of that treatment and not because of something else. For example, we wouldn't want to put 1 raspberry bush in the shade and 1 in the sun, because we don't know then if one produced more raspberries because it was in the sun, or was it because we gave it more water, right? So we need to keep everything the same. So what are some of those variables? I already gave one away, but what are some variables that could affect the amount of raspberries our raspberry bush produces? So I gave this one away a little bit. So you need to make sure that they have the same amount of sunlight. Both bushes should also have be growing in the same quality of soil. We want good fertile soil for our raspberry bushes. And then possibly we want to make sure that we have the same brand or same variety of raspberry plant, right? So all of those need to be kept the same for both groups. So this is what our experiment would look like. We would have group A, an experimental group, and group B, the control group. And if you look at the both of those groups, the only thing that's different is the treatment, right? The experimental group is getting an extra pitcher of water every day. Once we perform the experiment, right, we're going to be collecting our data over the harvest season of harvesting raspberries. And so let's say that our results are that group A, our experimental group, produced 8 quarts of raspberries, and group B produced 5 quarts of raspberries. So we use those results to analyze our hypothesis, and we're going to say whether we accept our hypothesis or we reject our hypothesis. And so in this case, here's our hypothesis. If I water the raspberry bushes each day, they will produce more raspberries. So do I accept or reject my hypothesis? We accept our hypothesis because group A produced more raspberries, right? So we were correct. Is it okay if our prediction is wrong? Sure it is. If our prediction or our hypothesis is wrong, we just have to go back and make a new hypothesis. Remember in the lesson it says that you know we write the scientific method in a linear fashion, but it really isn't always linear. We always have to go back and adjust things. So, well, thanks for watching.